નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Hello students, today we will study the question number 1 of exercise 10.3. This is the topic of standard 9, chapter number 10, circles. So what is the question? Question is draw different pairs of circles. How many points does each pair have in common? What is the maximum number of common points? So here we have to draw different pair of the circles. Suppose if we draw one circle like this and another circle like this. So here two circles we have drawn, but they are not intersecting. So no points are common in between these two circles. So no point. Now if we draw the circles like this, one is like this and another one is like this. So here we can say that one point is common in both the circles. So here we get the one point common in both the circles. In the same way, if we draw the circles like this, one is like, second one is like this. So here we get the 2 points as a common point. Now let us try to draw another circles like this. One is like this, another one is like this, one more like this, one another like this. So here also only one point is common between these four circles, right? So maximum number of the points when the two circles intersect, maximum number of the points we get is equals to 2 points. Only one condition is there: if the two circles have the same radius. What will happen if the two circles have the same radius? Then one circle is this, another circle is also on this circle. That means if the two circles are congruent, and if we put together both the circles one another, then all the points we get the common. So in that case we get the infinite number of the point, right? That is common in both the circles, because all the points of one circle is on the another circle. So if the two circles are not congruent, then maximum 2 points we get that are the common between two circles. Okay, you can also try to draw this kind of the pair, and you can also find out that how many points you get as a common point. Okay, so now let us study the question number 2. Question number 2 is, suppose you are given a circle, give a construction to find its center. Suppose here we have given one of the circle, right? This circle we can draw using any of the circular shape, like you can use the Bengal or any of the circular shape. Now here we have to find out its center. If we draw the circle with this compass, then obviously we know the center, but here we don't have the circle center of the circle. So how to find out? We can find out it using the construction. How we can do this? To do this, first of all, here we have to draw any of the two chord like this. First chord we can draw here, second chord we can draw let's suppose here. So this two chord we have drawn, right? Any of the length, it is not necessary to take the length of the chord equal, right? Any two chords you can take anywhere in the circle, any length, right? Anywhere, right? Now what you have to do is, you have studied about to bisect the line segment in the construction, right? Chapter number 11, how to bisect a line segment. So this is what this chord is, a line segment. So using your compass you have to bisect this line segment. To bisect this, we know that we have to take more distance, more than half distance of this chord. So approx you can take this much of the distance. Now you have to make an arc here and here. In the same way, on this, by taking the point on this point, you have to make the two arcs here and here. So if you join both these points, you get the perpendicular bisector you get the perpendicular bisector of this chord. In the same way, you have to find out the perpendicular bisector of this line segment. So here also you have to keep the point of the compass on the first point, then make an arc and one another arc here. Same way, by taking the point here, you can make the arc here and here. Now let us join. When you join this, again you get the perpendicular bisector of this chord. Now see, both these perpendicular bisectors are intersecting in this point, and that point will be your center of the circle. You can give it the name, right? So you can practice this thing at home by drawing the circle using any circular shape. Two things you have to keep in mind. First of all, draw the chords which are of the any of the length, right? Which have any of the length. One more important thing is, when you take the two chords, do not take both the chords parallel. Suppose you have drawn one chord here, don't take the one chord like this which is parallel to this chord, right? Okay, so you can draw any of the chord anywhere, and then you have to find out its perpendicular bisector. When this perpendicular bisector intersect in a point, that point will be your center of the circle. So in this way you can solve, you can find out the center of the circle. This is the basic construction. Now question number 3. Question number 3 is, if two circles intersect at 2 points, prove that their centers lie on the perpendicular bisector of the common chord, right? So here, suppose if we draw the two circles, this circle has a center, suppose O, and this circle has a center O dash. Now both the circles are intersecting in two different points. Suppose this is point A and this is point B. Now if we join this AB, we get the common chord. If we join this AB is what? The common chord, because it is the chord of this circle with center O dash. This is also the chord of the circle with center O. So the question is, if we join both this, if we draw the perpendicular bisector of OB, AB, that is the common chord, then that perpendicular bisect we get in this way. So both the centers must lie on that perpendicular bisector. That we have to prove. So let us do one thing. First of all, consider this circle, and according to the theorem, we have the theorem that if we draw the, first of all, let us take here AB is common chord, and let C is the mid point. If we take AB as a common chord and point C as the midpoint of the common chord. Now if we join center to this midpoint, what is the angle we get here? We get the angle is equals to 90 degree. One more thing, here we have taken C is the midpoint. That means we have taken that AC is equals to BC. Okay. Now here we have joined the midpoint of the chord and the center of the circle. So here we can write down that OC is now perpendicular to AB. Right? There is a theorem. See, the line draw through the center. The line draw through the center of a circle to bisect a chord is perpendicular to the chord. That is theorem 10.4. That is theorem 10.4. Right? If we draw the perpendicular from the center to bisect the chord means these two parts we have given that they are equal. Then this line segment is perpendicular to the chord. So we can write down that OC is perpendicular to A. In the same way, if we join this O dash and C, O dash and C, then what will happen? here also we can write down that OC is also perpendicular to AB according to the theorem 10.4. Now both these line segments OC is perpendicular to OB, OC is also perpendicular to AB. So here the angle we get that ACO or OCA, angle OCA is equals to 90 degree. OCA, and here we can write down angle OCA is equals to 90 degree. Both these angles are making a linear pair, so we can write down that angle OCA plus angle OCA is equals to 90 plus 90, that is equals to 180. So both these angles are making a linear pair, so therefore we can write down that OC and ODES are collinear. Collinear means all the 3 points lie on the same line. Now that on that line, both the centers of the circles are lying. Here we have proved that AC. Here we have taken that C is the midpoint of AB. That means this ODES line is bisecting AC and CB, two equal parts. AB is the bisector, and here we prove that the angle is 90 degree, and therefore we can write down that whatever the result we have asked here, that if we join the two centers, if we draw the perpendicular bisector of the common chord, then it will pass through the center of the circle, right? Okay, now let us see the question number theorem number 10.6. So the theorem is equal chords of a circle are equidistant from the center. Here we have taken one of the circle with center O. Let us take the two chords here, AB and PQ. These two chords are equal. Here we have given that AB is equals to PQ. Now equidistance from the center. What is the meaning of the equidistance and distance from the center? This is the chord. So if we draw the line segment here to here, we can also draw line here to here, here to here, here to here. Many lines we can draw. But which distance is called the distance? That means perpendicular distance, right? We cannot take this distance because here it is not making the 90 degree of the angle. So the meaning of the perpendicular distance, that means we have to draw a line segment which make 90 degree of the angle. So if we draw from here to here a line segment and it is making here a 90 degree of the angle, then that is called the distance of the chord. And let's suppose this intersecting point is R. And in the same way, the distance of this chord from the center, here also we have to take the perpendicular distance only, right? We cannot take the another distance, only the perpendicular distance. And let's suppose this intersection point is S. So here, this chord AB is at a distance of OS from the center, and chord PQ is at a distance of OR from the center. So according to this theorem, if these chords are equal, this distance are also equal. So therefore we can say that OS is equals to OR. If the chords are equal, then their distance from the center are also equal, right? Now the theorem number 10.7 is the converse. Here we have given that the chords equidistant from the center of a circle are equal in length. So here the given condition is, we have given the distance are equal, that is OS is equals to OR. Then we can write down that the chords are equal. AB is equals to CD. If the two chords are equidistant from the center, then their lengths will become equal. So this distance here we have given equal, so the chords will become equal. So these two theorems are also very important, right? We will use this theorem to solve the next exercise questions. Okay, so this is all about this lecture. Thank you. Thank you for joining us.